Hello. Today, my talk is Data Envelopment Analysis and Big Data. The main purpose of this talk is to talk about how data envelopment analysis, or DEA, should be used on big data. I will introduce some very basic concepts in DEA and show how DEA, as a tool that was proposed more than 40 years ago, have been evolving into something that's very different. And I will also talk about how DEA is linked with big data. Now, if you do a quick search on Google, say use the term data science techniques or data science tools, you will most likely, the first result page, you get a list of different, techniques and like linear regression, logistic regression, so lots of regression techniques, and some other type of method or techniques. You will not going to see, DEA in that list. However, this does not necessarily mean that DEA is not a tool for big data analysis, or even just for the sake of just call it data science technique. So I will show how DEA is linked with a data science tool, and I will also do a very brief literature review on the use of DEA as a productivity and a data science technique. So let's talk about what is DEA. If you've been working on DEA, you probably know DEA is just a ratio analysis. Or is it? What is it, right? So some of the basics here in DEA, we have a set of DMUs, or decision-making units. These DMUs can be anything from bank branches to a set of university, departments, retail stores, anything that you are evaluating, you are interested in doing a benchmarking study or a production analysis, for example. And then we also have a set of measures. I think this is the kind of the very basic thing in the DEA. You have to have two things. One is a set of DMUs. That's, you're going to have it because, if you're going to study benchmarking and performance evaluation, then a set of measures. If you look at the DEA literature, you will always see inputs and outputs, okay? The inputs and outputs. If you see that, you will immediately think that, you're looking at a production, right? So I have input resources and go through a production process, and then I get the outputs. However, this is not the case, actually. In DEA, and later on I will talk about, if it's used as a benchmarking tool, you basically group the measures into two groups, at least two groups. There are papers that's published to deal with that, the measures that do not fit into these two groups. So basically, what are the inputs? The input measures are usually the smaller the better, and the outputs are the larger the better. So now I usually in DEA use the symbol X for inputs and Y for outputs. However, we know that these are not decision variables as in mathematical model. These are observations. So you observe a set of DMUs, and then you have a set of measures. So you have data over time or across different units. So you try to figure out which units are the best practices, right? So the inputs will be the smaller the better, and the outputs will be the larger the better. But again, there are some other type of measures, and you can do a literature search on the DEA, and you can see those papers. I will not go into details with these types, so I just will focus on these two types, inputs and outputs. But just remember, inputs and outputs only make sense if you talk about the production technology. Okay, When you talk about using DEA as a benchmarking tool in general, the inputs are not the inputs you put into a process and then you turn it into the outputs. It's just a set of measures that you want the observations to be smaller, the better. And when you read the DEA papers, you will see what the DEA estimates efficiency scores, identifies best practices, in all these things. And some papers will say, construct composite indexes. Personally, I would prefer to call DEA as a user to construct a composite index. So that composite index, that particular index can be a risk index. There are papers about predicting or bank failure. There are papers in particular in healthcare areas that they use the DEA to build a quality index. That when you have a bunch of measures that reflect the quality of the care, how do you integrate them to get a composite index? So when you look at mathematically, this is what you see, right? So you have this is the Y, usually what I call the larger the better, or the outputs. If we talk about the production technology, but again, it's like a standard terminology. You always call them outputs, but back of your mind, you should always think about this is not necessarily the real outputs. So you see, this is a ratio. So it's a weighted sum of all the outputs and weighted sum of all the inputs. So in here, the X and the Y are observations. They are known. The things only unknown are the weights U and V here. Okay, so this is the ratio, right? This is the ratio. So it is a ratio. So now the question is, what does this ratio represent? This is a very key question when you want to use DEA. Right? You end up with a score, right? A ratio score. What does this ratio or score represent? You have to answer that question, and based upon, because there are two things I think going on simultaneously. One is what this ratio represent. But that depends on the measures that you use, right? What input measures you use, or what output measures you use, that will lead to what this ratio represents. And sometimes it may not have an specific economic meaning. It's just a composite index, which is fine. You can say, I want to define this composite index based upon this particular set of inputs and outputs, which is totally fine. So this is a very key question you need to think about before you do research or you apply DEA. So in my view, there's two lines of research in DEA. One is usually when you read the papers, you will see sometimes we'll talk about production and efficiency estimation. And the other line is it's a benchmark in general. So on the production, and you will see a return to scale. You talk about the EM model is you probably see a constant return to scale or variable return to scale. And then you have the assumption of the convexity, okay? And then, of course, the choice of inputs and outputs, it's very important because you're talking about production. You want to make sure the impact, the inputs that you choose will have an impact on the outputs in there. However, when you treat DEA as a benchmarking tool, you just want to see, you have a set of bank branches, and you want to see which ones are the best practices, right? So again, you still have the people still use the return to scale. However, in here, the return to scale may not necessarily be reflecting the economic definition of the return to scale. It's just the shape of the best practice frontier. Because when you have a set of bank branches or DMUs, you have observation. If we imagine you can plot this observations, and then you're gonna use a best practice kind of to envelopment all the observations. So that's why it's called a data envelopment analysis. And so what would be the shape, would be? So and we have papers on that, written on that. So I will not go into details in this talk. Hopefully this talk will give you some general ideas and some motivations so that you can go look for these articles. Now, the convexity assumption is not explicit in the original DEA model, in the original Chance Group rule that's published in 1978. I will show you that in a couple of slides. And also, it's very flexible in choosing the performance measures. One can use actual racial measures. So I mean, if you've been reading the DEA literature, so there are papers about you cannot use racial measures in the DEA analysis. You cannot use the racial measures when you do production or efficiency estimations. You have to use a different set of DEA models for that. But for general benchmarking purposes, you definitely can use the racial measures. So that there are debates or disagreement between among the scholars in terms of how can you use racial measures as an input and output in DEA. So my answer, it depends. It depends on what you want to do. And also, I want to point out that so in the previous slides, I showed you DEA is a racial analysis. So you have the outputs, divided by the inputs in there. But you have situations there where you only have the measures you want them to be the larger the better, or you have a situation that you want to be the smaller the better. So in this case, you will not have a ratio, but you still have an index, a composite index. So this is what's the conventional DEA. We'll talk about DEA, and you see a lot of videos when people talk about. This is probably a typical figure that you can see, right? So you have set up the MUs, right? And let's say these are bank branches, for example, and then you have the inputs and output inputs. Say the number of tellers, the salaries, the investment on the information technology and like ATM machines, for example, and then outputs you would have the number of deposits, transactions, loans, and so on and so forth. And then you have these arrows kind of going in, indicating that these are the inputs going in, and then you have the outputs for that's where traditional conventional DEA. However, what is the exactly, right? And I have a slightly different view on what is a DEA. I think it's more than production efficiency estimation, right? I've been, sometimes, I've been involved in an editorial position in different journals. And sometimes you send out papers to reviewers, and sometimes you see the review reports that are kind of interesting to me, because I still remember at one time I see a review report saying that, oh, you're talking about the production. How can you not use labor as an input? I mean, it is a very rational question, but when you have to look at a specific problem, maybe labor is not of interest, so you don't have to use labor as an input. I think the reviewer was thinking about a production, right? A production function. How can you not have labor and capital? In his or her mind, which is fine, but under the context of a specific application, you may not have that in it. So it's not necessarily production efficiency. It's a benchmarking tool, right? So Professor David Sherman and I, we published in 2013 in Slow Management Review. There's an article, if you're interested, and I would encourage you to read it. have a look. We kind of present DEA as a balanced benchmarking tool. Right? It's very well balanced because you have a set of measures that you want to be the smaller the better, and then you have another set of measures that you want to be not the larger the better. So we'll say it's a benchmarking tool. Really, it is a benchmarking tool. So under that context, the measures that you choose are the ones that you're interested in benchmarking the units, the DMUs. Here's another example, right, that I wrote with Professor Whitcock and Carlo Toni. And that paper was published. It's published in Omega in 2014. And we use an example, right? So in this example, so you're looking at say your benchmarking performance of the computers. Right? So you have the screen size, resolution, memory size, hard disk size, and anything else. So because you want to use DEA, so we use the standard terminology in DEA. We're still going to say, oh, these are the inputs, these are the outputs. However, as you can see here, the features, these are the computer features may not actually represent inputs and outputs at all, right? So if you have interest, go ahead and take a look at this paper. So let's revisit what a DEA is. This is how I would present a DEA. Again, you still have a set of DMUs, right? Instead of having the inputs and outputs, I will mark them as category 1 and category 2, right? So category 1 is a set of performance, metrics, and then category 2 is another set of performance metrics. And I also get rid of the errors. So you can see it's just the lines. That means these, the measures that are associated with this set of DMUs. So you can have multiple inputs and multiple outputs in there. Again, the category 1 or the inputs are the smaller the better, and the other side is the larger the better. And then this is the rule for classifying these metrics. So before you start the application, right, this is what you need to do, classify these measures. Now, and again, as I showed you before, you may only have category 1 measures, and you may only have a set of category 2 measures, which is fine, which is completely fine. You can do that. So this is how I would view what is DEA in terms of its basics. And again, here the definition of DMU is very generic. I mean, flexible can be anything, right? So here are some examples that in the literature now, I think it's more than 4,000 published papers in there. You probably can get a list of the DMUs from A to Z, from Air Force to Z, zoos. We'll look at these things. And again, when you read papers, the papers you often see, usually in the introduction, the very first 2 sentences you will see, DEA is a methodology for efficiency evaluation, something like that. I would think that that's a very generic term. Also, the efficiency sometimes is just a standard term. In DEA, it can refer to the overall performance. Right? Just the performance, or can be the production efficiencies. So you have to read the article to see what it's actually referring to in there. So I think it's a very, very general. It's not specific to production only. Okay. I would just say a composite index. You can say that too, because DEA has a history over past 40 years. So that's how the standard description of DEA is there. But I think we need to at least know the efficiency score does not necessarily mean technical efficiency scores in there. So let's take a look at the very first DEA model. Right? Just quick look at it. So you have this, ratio in there. The constraint here, because you want to maximize the ratio. Now, if you kind of inverse the ratio, then you're just going to minimize it. It doesn't, mathematically speaking, it doesn't matter here. You have to greater than equal to 1. You have to impose the less than equal to 1. Otherwise, this ratio is going to just go to infinity, and you're not going to get a solution. So here, you actually don't have to say it has to be less than equal to 1. You can say less than equal to 2, 100. It doesn't matter, right? Because you constrain it to be less than equal to 1. So, usually when you look at the papers, when you get a score for 1, you say that's efficient on the best practice frontier. And then this is nonlinear. You can, convert it into this. This is usually called a multiply model. So this is called a weights in there, but here it's actually called a multiply because there is a transformation involved, right? Mathematically, we get equivalent, but I still see papers call them these are weights, which is okay as long as you know these are not the weights in the original model. Okay, there is a transformation going on there, and then of course you have the dual model in there on the left. So this is usually called the envelopment model. So again, all these models X, Y are observations. Everything else are decision variables. For example, in here, the decision variables will be the theta, which is the efficiency score, or the composite index score, and then the lambdas. So let me leave this here for a while just to kind of talk about. If you look at the model on your right in there, this envelopment model, there's a line of papers that actually talk about this type of model that can be developed from, not necessarily from the duality in LP. It can be developed from just using a set of rules. So you get a production possibility set, okay? And then you can get this model. In there is a convexity assumption in there. But if you look at this original model, there is no assumption about that, the convexity. So once you have this, linear, multiply model, and then you look at the dual, and people say, oh, there is a convexity, okay, convexity. The convexity, I think, is important if you do research in economics in there, and it's because of the convexity. The use of ratio measures can be a problem. However, in the original ratio model, even in the multiply model, there's no convexity assumptions in there. So I think that's why you still can use the ratio measures in the model. So now let me talk about business analytics by data environment analysis. So what is there's a couple of things DEA are associated with. However, the last thing in here I kind of scratched it out. Support human decisions with visual analytics. This is not what DEA designed to do. I think DEA was actually designed to do all these three things, but not in the last thing, at least for now. Okay, at least for now. So you can get insights from the historical data. Right? You can actually use DEA as a forecasting tool. Right? There are papers on that. So DEA uses all we know is use linear programming technique, but later I will show you it's not because of the development in DEA. Nonlinear optimization techniques is also important for DEA also. So all these things that you can see are related to DEA. It's a business and analytics tool, DEA. Okay. Data envelopment analysis. Okay, so if you take out the envelopment, it's just the data analysis, right? DEA is actually data-based. It's what I call data-enabled. If there are no data, there's no DEA. We put environment in there is to reflect the best practice frontier, right? I mean, it is you use DEA to do data mining. You discover knowledge in the data, right? It's more than relative efficiency. if you think about it. So that's why I want after this, this presentation, hopefully that you can kind of have a broad view and an open-minded view about a DEA. It's not just about relative efficiency. Now, if you do production function, kind of research in there, yeah, you get the relative efficiency, you get the production efficiency scores. You still going to get that, but you get more than that. Okay. Let's remember, DEA is a data analysis tool. I want to briefly talk about the sample size. This, as I see a lot of people talking about, yes, certainly that's not enough DMUs. It's not enough inputs and outputs, for example. And remember, DEA is not a form of regression model, right? So in my view, it is meaningless to apply sample size. Now you can, it's nowadays it's a big data. You have a lot of, information, data that's available to you. So maybe sample size is not an issue. But again, if you look at DEA as a technique, you should not apply sample size. Let's say if you only have 5 bank branches in a certain region and you want to do a benchmarking study and you telling me that, well, there's only 5 banks, the sample size is too small, I cannot do it. Maybe you cannot do it, use a regression model, but in the DEA you still can do it. The other issue that I often hear is that, well, there's only 5 DMUs, and sometimes you may have too many inputs and outputs and end up with all 5 are efficient. Now, there's 2 sides to it. One side is that, so what? What if all 5 are efficient? Maybe they are efficient, right? Maybe they're doing a good job, so you want them to be efficient. So that's not a problem. The other side is maybe, it is an issue you're using too many inputs and outputs. So can you, reduce the number of inputs and outputs and use some other DEA techniques to do that? Certainly you can. I think some people heard of the rules of thumb, right? So the total number of DMUs had to be 2 times or 3 times, as the total number of the inputs and outputs. You can try that rule, but again, this is an empirical rule, right? There's no proof on that. So if you're doing a benchmarking study, I think it's fine if that rule is not satisfied. And we have papers that accepted or published that actually say that what if that rule does not satisfy? What would you do? Okay. So I just want to put the slide in there. Again, DEA is not a form of regression. Okay. So let's look at the past 10 years, right? The past 10 years. I did a research on that for the past 10 years, and when I look at these papers, you can see 3 major things. One is use DEA as a data-driven tool for descriptive analytics by gaining insights from the data. Okay, and the second thing is developing DEA models for studying network structure. So I will talk about that more later on. I think that this is really the future of DEA, the other research frontier of the DEA on the big data. And then, of course, combine DEA with some other data analysis tools. Okay, so that's what's happening, the 3 major things over the past 10 years. So as you can see, DEA has already shifting from just the standard, evaluation tool to look at, say, production efficiency, for example, and do more things that related to data analysis. So here's one paper that's published in the Omega. So they use the ES tool and they combine it with artificial neural networks to use them in organ transplants to improve the matching accuracy. And DEA, if you read the paper, I strongly encourage you to read this paper. Okay, the use of just the basic DEA model greatly improve the matching accuracy. This is very, very important. Okay, so as you can see here, DEA is not using the main tool. The main tool is still a neural network, but the DEA helps the accuracy of the neural network, and also as a result to help increase the matching accuracy. So that is a very interesting study, and when I go around making my talks, I often cite this work in there. And then there's some other combined uses of DEA with other data analytics tools. Okay, this is one study. Okay, so I just list the 3 studies. These 3 studies is going to be published in a special issue of JAWS, the Journal of the Operational Research Society, that we are editing on the data science and and productivity analysis. So I think we are almost done with editing of this special issue, and these are the papers that accepted in there. And I believe you can search for it just on the drawers. These are the names. Unfortunately, I don't have enough space to put down the full citations of the these 3 articles, but I'm sure you should be able to get them if you do the searches on inside this particular the JAWS journal. And then some other studies in the line of productivity and benchmarking. Right? So I just put these 2, papers in there. And I didn't talk about what's in there, so I actually put the full citations in there. Again, you can read that if you have interest in. Please go ahead and just have a quick read on that. These 2 papers I will not talk about in details in these two studies. Again, I want to emphasize that DEA is a data-driven or data-based or data-enabled technique. Right? So this is a article that's published in the International Journal of Production Research. So that's the title of the paper. From data to big data in production research, the past and the future trends. Right? So when you look at the paper, you can see the DEA is mentioned, right? In manufacturing, and DEA has been the most popular application area of data-driven technology methodologies. Okay, so I just want to point that out. So I've mentioned the network DEA. I said this is actually the research frontier of the future of the DEA. There's a lot of researchers are working on that. I would say a network DEA is a data-enabled analytics. Okay, it's still DEA. It's just like presented in a different way. In particular, I think it's used for under the big data. Now here, I do not necessarily mention the volume in terms of just large quantity of DMUs or the large quantity of inputs and outputs. Here, I'm talking about a different dimension of the big data, which I will talk about later on in the next couple of slides. Right? So it's still, DEA, data envelopment analysis, but I think we can also call it data-enabled analytics. What is big data, right? So you can Google it and you can get discussion or definition of what is big data. So I will not talk about that. However, there are certain dimensions in the big data. Right? You have 5 V's, and nowadays you probably have 8, 10 V's. But let's focus on the major, the basic V's. And the first one is the the volume, right? So again, that's a large amount of data, right? So here I put down a recent paper or work that we published in Azure. It's called a data envelopment analysis and big data. So and there we talk about how do you deal with a scenario have thousands of the DMUs. How do you calculate the efficiency scores quickly? Because there is under the big data that there is an issue of a real-time update, right? So you have thousands of DMUs. What if you, let's say if you taken the if you use the traditional DEA methodology, right? It probably takes you a day, maybe two, to finish calculating all the just the efficiency scores for the DMUs, right? But what if you want a real-time update in a couple of hours? I mean, how do you do that? So I think this technique is very useful for the real-time updating of the results. So this is the volume. So I think there are techniques can deal with the volume even when we talk before we talk about the big data. The researchers are still already working on developing techniques for dealing with the situations when you have a set of big data in there. But I think this technique is a little bit different, and I think it's very useful if you want to do real-time updating. And then the other view is the variety, right? The variety. To me, the variety means at least two things. One is that you have a set of different DMUs. Now, if you read some old papers on DEA say, DEA has to be homogeneous. I disagree. Okay. If you use the DEA as a benchmarking tool, and if you want to benchmark a set of companies, but the companies they do, for example, the companies have different activities, but some family focus on a specific set of technique, and then the other set of accomplished specific in a different set of techniques. And if you look at that paper that's published Azure at European Journal of Operational Research, we have examples in there. Just for the time's sake, I'm not going into details and give you an example. So when you have non-homogeneous DMUs, and if you wanted to do a benchmarking study of these set of DMUs, you still can't do that. Okay, so that's one area of the variety, variety of DMUs, and of course, then you have a variety of performance measures, right? So you have scale data, audio data, right? Even you have, what if you have this kind of also kind of, we kind of go into the area of the volume in there, too many inputs and outputs. We have techniques to reduce the number of DMUs, DES input and outputs. We have that. So we are developing tools for dealing with the variety of dimension of the big data. Velocity, right? So this is the speed. Are we updating in there? So I was just mentioning that this article is a possibility. I think personally, I think it is a good tool, to do that. But we are currently doing some, in my view, it's a conflict of interest for saying that, because we are doing that. Some interesting research on combining DEA or network DEA with a typical data mining, machine learning techniques. And we have some very interesting results, which unfortunately is not ready to be shared at the moment. We are still doing more testing in there. I think it's a very interesting line of research at least, and hopefully that people viewing this video are actually data science, researchers, and you may have a better knowledge than me in terms of all these machine learning techniques. Right? So when you understand the basics of the DEA, of the network DEA, which I will talk about soon, and hopefully some new research ideas can come to you, right? For us, I'm a DEA researcher, so I know very well what is DEA, but I don't know very well in terms of this machine learning techniques, the existing machine learning techniques. So I tend to develop a new line of research by combining DEA and machine learning from the perspective of DEA, because I know that well. That's my comfortable zone. But if you're coming from a different research area, and and look, then when you look at DEA, you may get some very, very different idea. So I think this is a huge potential for future research under the big data value. That's the dimension I see the network DEA can make a contribution into the big data, under the big data. When you look at, say, sometimes the number of units, DMs, and inputs and outputs has a limitation in that. You cannot have infinite number of bank branches for them, right? So when you look at the value aspect of the big data, I think you can get a very interesting, a very different aspect of the value, right? What is value? What is value? When you have a big data, so you have lots of units, lots of different measures. Instead of treating all the measures as the smaller the better, the larger the better, all the inputs and outputs, maybe you can put these measures into or linking these measures in a network structure. What do I mean by that? Here's one example, right? So this is one example I'm taking from an airline. Okay, so you have the airline capacity, then you have the operation, you have the fleet size, you have all the costs associated with it, and then you have all the revenue, passenger miles associated with it. Again, in here, this is just an example. There's a lot of lots of measures in there. You can probably put them together. You can say, we're going to look at the airline performance. But the question, what does the performance mean? Right? When you look at it, maybe you mean capacity in airline operations. If that's the case, should you separate them? Right? So this is what I call a network structure. Instead of putting them together, you can see the fleet size actually linking the two different aspects of the airline performance together, right? So if it were production situation that you have, you go through a multi-stage production process, right? And then we have a paper published, several years ago about measuring the performance of the supply chain, right? In supply chain, you can look at supply chain as a whole, but in supply chain you have different members, right? So each different members, you have links, linking, measures together, you link them together. So when you open up the DMU as a black box, you look at the internal structures, that you can extract additional information, which I call value, from the DEA analysis. Such information or value, you cannot get them by using the conventional DEA. You have to use the network DEA. Okay, so as you think about, the simple description of network DEA is you look at the internal structure of a DMU. But on the other hand, when you look at supply chain or even like transportation logistics systems, when you evaluate supply chains, you actually define the measures that are related to the supply chain component first, and then you sort of have the entire DMU of the supply chain system. So you are, technically you're looking at the internal component of the supply chain if you define the supply chain as a DMU, but you actually start off with the component first. So it's really about the network structure. Now let's take a look at this this study. This is the study that will appear in the JAWS This is actually part of the special issue that I was talking about, data science and productivity. So this is a study about, let's say you go from, you're a driver, you go from point A to point B, and you go through different routes you can go. Let's say during the traffic hours, there's sometimes part of the roads will have a traffic congestion. And some people use a GPS kind of to navigate through to try to avoid, the congested part. But if you think about it, if everybody is using the GPS system, then the congestion will just probably going to move from one part of the road to a different part if the GPS routes everybody to a specific road. So the research issue here is to look at in what portion of the people that use the GPS that's best for the road congestion. So this is really a production theory model. It's purely it's try to build a congestion index. So it's really a purely composite index approach by using the DEA. So they have the simple roads in there, the networks in there. These are the measures that they use. They build a network DEA model. Okay, so they have the inputs. The measure goes into the first stage, and then they also have those intermediate measures, and then finally the outputs coming out. So really, I think they define the inputs and outputs as the smarter the better, and the larger the better the outputs. The intermediate measures, if you think about it, is the measures that link the two stages. So depending on how you define these measures and how each stage you would like them to be, it depends. So for example, in this case, I believe in the first stage when they're coming out, you want to be the larger the better, or when you're coming into the second stage, the smaller the better. It's sort of like output coming out and coming into the second stage as the input. However, you can also think about the linkage between the two stages as something you don't know whether the larger the better or the smaller the better. You want the two stages to decide, what's the best value. So if you think about supply chains, two members of supply chains, some coordination trying to decide the measures link these two stages in there. And this is the simulation. They did the congestion index, as we can see, somewhere between 70% and 80%. The people that uses GPS, they get a congestion index that has the highest congestion index. So I think this is a very interesting study. It's a very novel use of a network DEA to get values. In this case, the value would be the congestion status. Here are some more examples of a network DEA models or structures. We have this parallel structure on the left, and then a mixed structure. You have a parallel structure, but you also have kind of a relationship in a series. Okay, and then the other type of network DEA model is a dynamic structure. You have this dynamic impact from the time that you go different periods over time. So this is another dynamic structure. So let's take a look at the mathematical models very quickly on a general two-stage network. So here I use the arrow. You can kind of have the input come in, but it depends. If it's not a production model, you don't have those arrows in there. So in a sense, this picture gives you a sense that, so you have a linkage, which is the Z, okay, variables. I mean, it goes from 1 to 2, but in reality, you may have something goes from 2 to 1. It depends. And also from 2, everything goes up, but it can have a feedback measure. It goes back to 1. And we already have those studies published in the journals. So this is sort of a journal a general two-structure network. So all the x's, y, and z's are observations in there. So if you were to use the ratio to build a model, so this is your objective function, and then these are the weights in there. One of the key thing here I would like to point out, if you pay attention to the weights here, this eta here. So this is like the outputs, and this is like the input, but it's the same area, it's the linkage in between the two stages. The weights are set to be the same. Okay, at least in this particular network model, the network modeling here. And these are the just the regular ratios in there. So this is the model. Unlike the standard DEA model, this model, the alpha is just the weights. You just specify the weights. You can also set this as a variable too, but just will make this model more more nonlinear. As I was saying, unlike the conventional DEA model, this cannot be converted into a linear model. No, just can't. Okay. The other approach is just to build a PPS production possibility set. Okay, you can do that. So that's the kind of the environmental side. And from there, you can also build a environmental model. Okay. And here in the multiplier model, the ratio model, you set the weights are the same for the link, and here you kind of have this these equation in here to express the linkage between the two components of the two stages of the network. What's interesting here is that the environmental model actually generates the overall integration and efficiency scores. Okay, but where is the frontier? Where's the frontier from that environmental model? And no one has bothered to show where the frontier is. So this is, I think, a much needed research here in network DEA. So some other type of research that you can do on the network DEA is the relationship between the multiplier and the invariant network. Okay, it's not like because it's a nonlinear, there's no duality at all. Where is the frontier? And scale efficiency. When you studying a production system, if it's a network structured production system, you have a variable to scale, constant to scale, for example. So where the scale efficiency. And obviously, nonlinear optimization is very, very important for network DEA. So this is a kind of brief story. Again, DEA uses in transportation and logistics. In the past 20 years, there are about 600 articles. Most of them are using conventional DEA, focusing on efficiency and productivity. Last 5 years, about 180 papers, of which 35 they use a network DEA. So they started to use network DEA in transportation and logistics system. It's kind of interesting if you think about it. The transportation, you go from one point to another, and another point in the logistics system. It's a nature of a network structure. I think we ought to use network DEA to revisit some of the studies in there. So this is a pie chart on the different research field in related to transportation and logistics and supply chain kind of stuff. So this is again the conventional DEA for big data. So as I mentioned, this is one of the recent articles that we published in journal. Actually two, the second one. So both dealing with different aspects. So one is the, I believe the second paper is published. So by the time I was doing the slides, I think it's still in press, but I think it's published. One dealing with how you can get the frontier, identify the best practice to use quickly. And the second one is that if you have too many inputs and outputs, how do you address that? So finally, I would like to share with you this big data and DEA. Big data has been around. The concept of the big data has been around for several years, and I'm just interested to see if anybody actually mentioned big data in their DEA studies. So this is so we did a Web of Science search, okay, and we get about 40 or 38 studies. After we delete those duplicates, sometimes the paper was counted several times. A significant number of studies are carried out for environmental issues under the context of big data. So again, this is the JAWS special issue I was talking about earlier, and it's big data for better productivity. So basically, in this special issue, we're looking for papers, not necessarily pure DEA papers, but I think we ended up with several accepted papers that I used DEA with some authorities. So this special issue is almost done, and most of the accepted papers, I believe you can find them already online on the journal website. So I highly recommend you to take a look at the papers in this issue. So I would like to just say this is the actually part of the data envelopment international conferences that I'm organizing for past 3-4 years. We think that data envelopment analysis on the big data is really a data-enabled analytics. This is the new direction that we want to go under the big data. And if you think about it, you have to, again, I would say at the very beginning, you have to have data in order to be able to use DEA. So really, we are, about 40 years ago, we have DEA. Now we have DEA squared. This is the really an exciting movement and a good opportunity for all of us to make some contributions, some new and significant contributions by using DEA on the big data. And finally, we are Professor Winston Charles and I, we are editing a book for Springer, the International Series in Operational Research and Management Science. It's called Data Enabled Analytics for Big Data. And we welcome submissions. And if you have any questions, please feel free to contact me or Professor Winston Charles. And with this concludes my talk. If you have any questions, comments, or suggestions, please feel free to let me know. Also, this is the website. You can look at my new explanation, new view of DEA.